Hi everyone, welcome back to Eve Math Tutoring. Today's lesson is on linear regression, estimating the line, or also referred to as the equation of best fit for data. This method is also called the least squares method. This is a method commonly used in statistics. So, regression determines the relationship between a dependent variable and an independent variable. So if you want to estimate the line of best fit for data, say in a scatter plot, then what we would do is use the least squares method. And what I mean by that is if you had a scatter plot for some specific values where you had y and x, and you had some data, and you wanted to know for this data what the line of best fit would be to represent this data, that is when you would use the least squares method. Okay? It's also referred to as linear regression, and we use this method to find the equation for the line of best fit. So this equation is actually the line of best fit in the least squares method is given by the following. So it's given by y is equal to ax plus b. And in this equation, a is equal to n, which is the number of values in your data set, multiplied by the sum of your x's and y's, minus the sum of all your x values, times the sum of all your y values, divided by n, which is the number of values in the data set, times the sum of all your x values squared, minus the sum of all your x values all squared. And b is given by the average of y minus a, which is this a here, times the average of x. So those are the equations you use to find the line of best fit for data or for any scatter plot. Okay, now here I just want to go over what these are. So n is actually the number of values in your data set. Okay, and as you remember, I had mentioned in a previous video that this here represents the sum of. So that symbol represents the sum of. So whatever's in front of it, you just add those up. And then x just represents all your x values. Y, so those would be your, so between your independent and your dependent values. So x and y represents, okay, so y represents all your y values, and here we have x squared and the sum of, so you square your x's first and then take the sum, and here we've got the sum of all your x's and then you square that final value at the end. Okay, so this here is the least squares method. So we're going to actually use these to do an example. So say you were given the following data. So you were given the following data and you were asked to say, so for example, we have the following table which shows data for full-time employees of a small company. So you're given the age on one side, which is in years, of the employees, and on the other side you have their annual income. Okay, so you have the following data for some full-time employees of a specific company. And you've got the age on one side, and then the annual income, which is in, okay, so these, we're going to assume these are in thousands. So the first person is 33 years old and they make $33,000. 25 years old, person makes 31,000. 19 years old, they make 18,000. 44 years old, and they make 52,000. 50 years old, and the person makes 56,000. 54 years old, and the person makes 60,000. 38 years old, and they make 44,000. And then 29 years old, and they make 35,000 today. So that goes with that, that goes with that, that goes with that. So you're given this data, these are all in thousands, and you're asked to say, find the equation of best fit for this data. Okay? Now, first of all, for something like this, you could also be asked to draw a scatterplot, use a scatterplot to classify the correlation between age and income, like to see if there's a correlation, is there a positive correlation, a negative correlation, etc. And to do that, you would have to actually graph this data. So say the first part was to classify the correlation between age and income, and then part B of the question could be find the equation of best fit, and that's where we would use the least squares method and those formulas I showed you earlier. Find the equation of best fit. Okay, so to find the equation of best fit, we would be using the linear regression, and we would be using the least squares method. So let's go ahead and do that. So over here, if we actually were to figure out the relationship between income and age, if we were just graphing on normal grid, 20, 25, 30, and 35, and 40, 45, 50, 55, and then on this side we would have the income, $15. So actually this should be farther from the origin because I'm going by fives here, so I'm actually going to redo this. Okay, let's redo this. Let's go 15, 30, so we're going to go by 15, 45, and 60, and let's go 15, 30, 45, and 60 over here. So, okay. Now, so our data we were given, we had the table. So what you do is just plot each one. So age, the first one, the person was 33 and they made 33,000. So the income is in thousands. We're going to assume they're in thousands of dollars. So the person was 33, so that would be around here somewhere, and they made 33. So we put a dot there. The next person was 25, so that would be somewhere over here, and they made 31,000. The next person was 19, and they made 18,000. The other person was 44, and they made 52,000. The other person on our list was 50, and they made 56, so that's somewhere over there. The other person was 54, and they made 60. And then we had somebody who was 38 who made 44, and another person, last person was 29 and made 35. So definitely look, like if you look at the data, you could see that there is definitely a positive correlation between age and income in this particular data set for these people in this job. Okay, so or for our x and y. Like so in this case, age would be our x and income would be our y. Age, so x is your independent variable. So age obviously does not depend on how much you make, but how much you make is dependent, so it can depend on your age. So this is our dependent variable. This is our independent variable. Okay, so there, that will go like that. So now, when you want to, now you've got your, so you've got your positive correlation. So if you see the data going upward from left to right, that's obviously a positive correlation, because as one increases, so does the other. So as the independent variable increases, so does the dependent variable. So that means that there is a positive correlation between the independent variable and the dependent variable. So if it was going the other way, that would be a negative correlation going this way. And if it was just like scattered and straight, then that would be no correlation. So you kind of have to see how the data is. If it was just scattered all over the place, again, probably no correlation there. But if one increases as the other, then that's positive. If it was going this way and decreasing as the independent variable increases, if the dependent variable decreases, then that's a negative correlation between your independent and dependent variable. Okay, now what we want to do here, now if you're asked to find the equation of best fit for your data, okay, so you could be given just, you know, a data set, find the equation, equation of best fit, So you're asked to find the equation of best fit, and this could be for any data. You could just be given a set of data and asked to find the equation of best fit, or you could be given, like you could just be given a, you know, okay. So you want to find the equation of best fit for some specific data. So it could be a table like this, it could be a graph like this, or it could be a table of values. Okay, so what we're going to do is we're going to actually look at our table. So for this same question, so we already know that our age, the values for age were given, and we had, that's going to be our x variable, and we had our income, which is going to be our y variable. And the reason for this is because x is your independent variable, and age is obviously independent of everything else. It does not depend on how much you make, but how much you make can depend on your age, so that would be the dependent variable, which we would put as our y variable. Okay, and then we're going to use our, so we were given, the data was already given to us in the question. And income was also given. Okay. And over here we've got our x squared value and our xy. So the reason I'm doing this is because I'm going to use that in my formula. Okay. So in our formula we're going to find the line of best fit. So we know that the line of best fit is given by y is equal to ax plus b, and we know that a is going to be equal to equal to n times the sum of xy minus the sum of x times the sum of y, all over n times the sum of x all squared minus the sum of x. Sorry, this one should be the sum of x squared, and this is the sum of x all squared. So we've got y, we've got a, and we know that b is equal to y minus ax, where y bar is the average, so mean of y, or average, and x bar is the average or mean should be a line here, mean of x, okay? So we've got those. So what we're going to do now is go ahead and figure out all our x squares. Now these are in thousands, but we're just going to use the regular numbers. Okay, so we figure out our x squared values, so we just take our x's and square those values. And when we do that, we get the following. So 19 squared is 361. 44 squared is 1936. 50 squared is 2500. 54 squared is 2916. 38 squared is 1444. 29 squared is 841. And then you take your x's times your y's, so 1089, 775, 342, 2288, 2800, 3240, 1672, and 1015. So just squaring so multiplying the x times the y. That's how I got these values. So 33 times 33, over here 29 times 35, so you get it there. And then at the bottom of your table, what you want to do is take the sum of each one. So sum of all your x's, so add all your x's up and you get 292. Over here you sum up all your y's, add up all your y's, you get 329. Over here you add up all your x squares. And when you do that, you get 11,712. Over here you sum up x times y, which is equal to 13,221. Okay. So when you do that, you get all your sums, and we can also figure out our average for x. So to figure out the average for x, you add up all your x values and then divide by the total number of x's that you have. So all of our x values here are 292 divided by however many values we have. Well, we've got 8 values, so we just divide by 8. We get 36.5. Over here, you take all your y values. To find the average of y, you add up all your y values, which is, you take the sum of your, actually we could do the formula for that. The sum of your y's divided by n. So however many y's you have, so you add those up, you have 329, and you divide by 8, you have 8 values in total. And then you get 41.125 as your final answer. So that's the sum of y, and over here we've got the sum of x. Now once we get all this, we can go ahead and plug them into b. So b is equal to y minus a times x. Now did we calculate a? No, we didn't. So I should have done a first. So going back to the previous, so over here, now using all these values, I'm going to actually calculate a over here. Okay, so a is going to be equal to, let's see here. Okay, now a, if I want to calculate a, equals, it's just going from here. So n is equal to 8 because there's 8 values for n. We've got 8 values. It's not, n is not the total number of values, it's the number of values you have for each variable. So your n value here would be 8. Okay, so that's important. That can be easily mixed up and misinterpreted in the formula. So n represents the number of values for each variable. For each variable, so not combined. So that would be equal to 8 in this example because each variable has 8 values. Okay, so that's important. So here you just plug everything in. You've got 8 times the sum of x times y, which we have right here, 1321, minus the sum of x, which I have over here. The sum of x is equal to 292, so I put that in, 292 times the sum of y, which is 329, divided by, on the bottom we've got n again, which is 8 again, times the sum of x squared. So your x squared, and then you sum them, you square them first, and then, the sum of all your x's squared. So you square them and then add them up. So that's going to be 11,712. And then here we've got the sum of x all squared. So that is the sum of x. So you add them first before you square the x's, and then you square that value. So that's going to be 292 all squared. So that part's a little bit tricky too. You want to watch for that. This is the sum of x's squared. And this, as you can see, the square is outside the bracket, so that means you have to add up the x's first and then square it after. Here you have them squared and summed within one bracket. So that means they're squared first, the values, and then added. Here, you add them first and then square them after. So you have to see the way it's written. Okay, so these two are not the same thing. These two are two different values. Okay, so this and this are not the same. Okay, so when we plug everything in, so here we've got the sum of x, so sum of x all squared. When we do that, now you just use bed math, just multiply, and first multiply so 8 times 13,221 minus, and then multiply these two. When you do that, you get 9,700 on the top. On the bottom, you want to square this first and then multiply these and then subtract. So again, you're using BEDMAS, always keeping BEDMAS in mind, the order of operations. You can never do subtraction before you do exponents or do subtraction before you do multiplication, right? So you have to make sure you do the multiplication here, do the exponent here, and then subtract the two values, okay? Or else you will not be getting the right answer. So if you do that correctly, you're going to get 8,432. And then your final answer is 1.15. So you get your A value there. We got our average for X and our average for Y. And then we use all that information to plug it in the so we had our average for X and our average for Y. So we got our A value as well. So A was equal to 1.15. Our x bar was equal to, our average of x was 36.5, y bar was equal to 41.125, and then our b is equal to y minus ax. Now this is also a formula, like the formula for A. Those are formulas, they never change. That's what I mean when I say formula. Formulas do not change, ever. So they're just concrete formulas that always stay the same. So that's a formula as well. This is also a formula, the average of x. Oops, that minus isn't in there. And the average of y is also a formula, which never changes. So formulas are consistent in math, they don't change. So now we're going to plug these values in to find our b. So y bar is 41.125 minus a, which is 1.15 times x bar, which is 36.5. So when you multiply them out, multiplication first, then subtract, you get negative 0.85. And now we can write our equation, which is y equals ax plus b. This is also a formula. So this also does not change. So plugging these in, we get 1.15x minus 0.85 because we had a negative b value. This right here is our formula. This is the line of best fit. So that there is the equation for the line of best fit for that specific data. So when we had that data and we graphed it in a scatter plot like this, the line of best fit is the line that's perfectly centered and represents your data in the best way. And to find that actual equation for the line of best fit, we use the least squareds method, which is what I just went through right here, okay? So this is linear regression. It's the line of best fit for data, how to find the equation of a line of best fits. All right.